welcome to next lecture of hybridization and aromaticity. In this lecture, again we will discuss some problems of organic compound and try to find out whether they are aromatic, anti-aromatic or non-aromatic. So these are the 4 examples. यहाँ से शुरू करेंगे. फर्स्ट एग्जांपल जो है साइक्लिक पॉलीन. साइक्लिक पॉलीन्स आर एक्चुअली annulenes. So this is an example of 16 annulenes. 16 annulenes. So what is annuline? Is a cyclic polyenes. So 16 that represent the number of carbon atom. So this out of the aniline, if we take 10 aniline, 14 aniline, then we have 16 and 18 aniline. Out of these 10 and 14, they are non-aromatic. So annulenes are just to check the validity of Huckel's rule, where it works and where it is not working. So these are, we have various types of annulenes. हमारे पास काफी annulenes हैं जिसमें हम Huckel's rule apply करेंगे. तो जो smaller ring है जिसका size 6 membered है, 7 membered है, they are in one plane. But जब ring का size बढ़ जाता है तब वो जो कार्बन एटम्स हैं they will not remain in a one plane, so they become out of plane. जैसे एक एग्जांपल पहले हम कर चुके हैं, ये साइक्लो ऑक्टा टेट्राईन. तो इसकी जो इसका रिंग साइज इतना बड़ा है because it is due to the big ring size, it is under angle strain. So to get stability, it change itself into a tub shape structure. So that is not planar. That's why हमें इसको बोला था कि this compound is not planar. Why it is not planar? Because of big ring size. इसका ring size ज्यादा है. It become under angle strain. अगर ring size बहुत छोटा होगा, like मान लो कि हम ब्यूटेन पे जाएं, तो इसमें रिंग स्ट्रेन इसलिए है बिकॉज इसका जो एंगल है वो 90 डिग्री है. होना चाहिए टेट्राहेड्रल कार्बन का एंगल 109.28. अगर रिंग का साइज बड़ा हो जाता है 6 मेंबर से तो भी उसमें एंगल स्ट्रेन शुरू हो जाती है. तो तब वो मॉलिक्यूल अपने आप को किसी स्टेबल कॉन्फ़िगरेशन में ले जाता है. तो इसी वजह से ये जो साइक्लो ऑक्टा टेट्राईन है ये अपने आप को टब शेप में ले जाता है. वहां पे ये ज्यादा स्टेबल है. तो दैट्स व्हाई हमें इसको लिखा था कि दिस मॉलिक्यूल इज नॉन प्लेनर और दिस इज नॉन एरोमेटिक. दिस इज आल्सो एनुलीन, सो यू कैन से इट्स 8 एनुलीन्स. सो 10 and 14 एनुलीन्स दे आर नॉन एरोमेटिक. 16 that is anti-aromatic and 18 aniline is aromatic. This is your 10 annulenes, so you can say or it is non-aromatic because these two rings are not in one plane, but we can make it aromatic by doing some modifications. So now this is 16 annulenes. There are how many double bonds? 1, 2, 3, 4, 5, 6, 7, 8. Each double bond contribute 2 p orbital. Like this, जैसे हमने पहले किया कि इसका p, इस कार्बन का p, इस कार्बन का p, ऐसे करके we have 2, 4, 6, 10, 2, 4, 6, 8, 10, 12, 14 and 16 pi इलेक्ट्रॉन. तो अगर इसमें 16 पाई इलेक्ट्रॉन है तो ये किसको फॉलो कर रहा है? 4n पाई इलेक्ट्रॉन को. तो इसका मतलब है ये मॉलिक्यूल क्या हो जाता है? एंटी एरोमेटिक. तो एनुलीन्स में जैसे ये 10 और 14 हैं, ये दोनों नॉन एरोमेटिक्स हैं. 16 एनोलिन जो है वो एंटी एरोमेटिक है और 18 है जो एरोमेटिक है। दूसरा मॉलिक्यूल ये 10 एनोलिन है। 10 एनोलिन, ये भी हमने लिखा है नॉन एरोमेटिक। Why it is non aromatic? Because it is not flat. It is not flat, so this is also non aromatic. But we can make it aromatic by doing some modifications, so that I am doing here. So if we change the structure of this 10 anolines like this, by inserting a methyl CH2, by inserting a methylene group between these two carbon, so the structure becomes this. Now this molecule become aromatic because now it is in one plane and it has total 5 pi bonds, means 10 pi electrons. So 10 pi electrons follow this 4n plus 2 Huckel rule, so it is aromatic. Other ways, we can also change its structure like this. Put here oxygen. Instead of methylene group, you can also insert oxygen. Again it is aromatic. One more way we can change its structure to change it into naphthalene. So naphthalene is like this. So it has 10 pi electron. So this is also aromatic. So in this way 10 anolines can be modified to some aromatic compounds. By inserting methylene group or by inserting oxygen, you can also insert sulfur or nitrogen here, and by changing into a naphthalene. So this is about the aniline. So anilines are basically, you can say, cyclic polyenes. Polyenes means having a number of double bonds. So 10 and this is your 10 aniline, 14 aniline, they are non-aromatic, and 16 is anti-aromatic, and 18 is your aromatic. So next compound is this having 2 cyclic ring. So as example last lecture में भी थी, and we have to move this double bond either in this direction or in this direction. So from this we can find its aromatic character. Suppose we are moving it in this direction, so it will be changed to this molecule. तो ये नया मॉलिक्यूल जो है ये बन जाएगा, यहाँ पे नेगेटिव, यहाँ पे पॉजिटिव। अगर आप इसको देखोगे रिंग वाइज, मैंने बताया था पहले फर्स्ट रिंग देखेंगे, फर्स्ट रिंग में है 2 इलेक्ट्रॉन्स, 2 ये हो गए, 2 ये हो गए, दिस इज 6 पाई, तो दिस इज योर एरोमेटिक। सेकेंड रिंग में देखेंगे ऑल द कार्बन एटम्स दे आर sp2 hybridized, it means compound is flat, so we have 2 plus 2 plus 2, 6 pi electrons again, so this is also aromatic. So overall this molecule is aromatic. Okay, now last example. In this, how we will decide whether this molecule is aromatic or anti-aromatic or non-aromatic. Just push the electron here like this. So when you push the electron like this, you will get another structure having a double bond here, and triple bond n हो जाएगा पॉजिटिव चार्ज, और यहाँ पे आ जाएगा नेगेटिव। Means polarization. Again, it is an example of quasi-aromatic. Now we will see the number of p electrons. So there are 2 plus 2 plus 2, 6 pi electron. So this compound is also aromatic. सो ये 4 एग्जांपल थी जिसमें मैंने थोड़ा सा एनोलिन को कवर किया, और एनोलिन्स में मैंने डायरेक्ट आपको बता दिया कि एनोलिन्स क्यों बनी है. एनोलिन्स आर यूज्ड टू चेक द वैलिडिटी ऑफ Huckel's rule. Some Anolines are basically a large cyclic compounds having a large number of double bonds, so that they are cyclic polyenes. So when the ring size become more than 6 or 7, they will not remain in a one plane. They want to attain extra stability, that's why they will go out of plane. That's why some of them become we can say non-aromatic, like these 10 anolines. Or we can change it into aromatic by doing some modification, like when we insert the methylene group here. This methylene group is above the plane, this oxygen is above the plane. When this oxygen is above the plane, it keeps the 2 rings in one plane. So when the molecule become planar, so that fulfill one of the condition of Huckel's rule. So this oxygen that helps to make the 2 rings in one plane. So when it become planar, next job is to count the number of p electrons. So there are 10 pi electrons, so it become aromatic. So this is all about the aromaticity and hybridization, how we use the hybridization in aromaticity to find out whether the compound is your aromatic, anti-aromatic or non-aromatic. Now next we will see some applications where the aromaticity is used, or how many types of questions can be asked in various competitive exams starting from JEE Main, NEET, IIT JAM and CSIR NET. So सबके लिए है, क्वेश्चंस आर कॉमन बिकॉज एक ऐसा क्वेश्चन भी मैं डिस्कस करूंगा जो JEE Main में भी आया है पेपर में और CSIR NET में भी आ चुका है. तो लिखेंगे एप्लीकेशंस ऑफ एरोमेटिसिटी. इसमें मैं वो चीज बताऊंगा कि इनडायरेक्टली एरोमेटिसिटी से क्वेश्चन कैसे पूछे जाते हैं. तो फर्स्ट इज ऑर्डर ऑफ एसिडिक स्ट्रेंथ और pKa. आपको कुछ मॉलिक्यूल्स दे सकता है ऑर्गेनिक कंपाउंड और बोलेगा कि अरेंज देम अकॉर्डिंग टू देयर इंक्रीजिंग एसिडिक स्ट्रेंथ, और क्वेश्चन आ सकता है अरेंज देम अकॉर्डिंग टू देयर इंक्रीजिंग pK वैल्यू. सो pK वैल्यू दैट give information about the acidic strength that is related to Ka like this. So अगर Ka that is a dissociation constant for acid, अगर आपका Ka ज्यादा होगा एसिड जो है वो स्ट्रॉन्ग होगा, लेकिन तभी आपकी जो pK वैल्यू है वो लेस होगी. तो आप pK वैल्यू के हिसाब से भी अरेंज कर सकते हो. अब यहाँ पे एसिड की जो स्ट्रेंथ है उसका मीनिंग क्या होता है, हम यहां से लेंगे टेंडेंसी टू रिलीज H पॉजिटिव आयन. जो H पॉजिटिव आयन इजिली देगा उसको हम स्ट्रॉन्ग एसिड बोलेंगे. तो इसमें मैं एक एग्जांपल ले रहा हूं. 3 कंपाउंड्स दिए हुए हैं उसने और बोला है अरेंज देम अकॉर्डिंग टू देयर इंक्रीजिंग स्ट्रेंथ, एसिडिक स्ट्रेंथ, और ये भी बोल सकता है कि अरेंज देम अकॉर्डिंग टू द pK value, increasing pK value or decreasing pK value. So these 3 compounds are given. So इसको लिख लेते हैं हम, compound number 1, 2 and 3. Now how to decide? So options हो सकते हैं इस क्वेश्चन की, like A option is A, C, B. B option is A, B, C. C option is C, A, B. और D option हो सकती है B, C and A. So let's see how to solve such type of questions. This is based on the aromaticity. Now, when first of all we have to change these molecules, how these molecules look like when they give H positive ion. सो आप H पॉजिटिव आयन यहाँ से निकाल दो, H पॉजिटिव आयन निकाल दोगे तो यहाँ पे नेगेटिव चार्ज आ जाएगा। तो आप इन मॉलिक्यूल को ऐसे लिखेंगे, इसका भी H पॉजिटिव जाएगा तो नेगेटिव चार्ज इधर आ जाएगा। तो these molecules change into ions when they give H positive. They will look like this. Now find the aromatic and non-aromatic. So it has a 6 pi electron, it's aromatic. It is a 4 pi electron, it's anti-aromatic. And it is a you can say 8 pi electron. So this is your it's your anti-aromatic. So these are the molecules. Now from this we can directly find that this molecule is aromatic. When this molecule gives H positive, it will going to change into aromatic compound. So aromatic is more stable. So it means when this compound gives H, it change into more stable molecule. So this process is very much feasible. It means the most acidic out of these three is this one. Okay, take it A, B, C. So your A option, A compound is the most acidic. So option A and B आपकी सही हो रही है, C and D cancel. Now both these molecules in B and C, they are actually anti-aromatic. Now out of these two anti-aromatic compounds, what will be the correct option if we choose? So your C is little bit more stable than this B because it's a 7-member ring and it is your only 3-member ring. If you compare, because now these are anti-aromatic, so then how you can explain, how you can compare the you can say the stability of these molecules. That can be done by resonance. So in this case the negative charge is more delocalized as compared to this. It means whether they are anti-aromatic, both are anti-aromatic, but out of these two, this 7-member ring, due to more delocalization of negative charge, become more stable than compound this B, which given by B. So it means this molecule C that can give that will give H positive ion easily as compared to this, because it's going to form a much more stable than this. This is anti-aromatic, this is anti-aromatic, but still we can compare the stability by using the concept of resonance. So here the negative charge is more delocalized as compared to this. So your correct answer is A, C and B. So ये था फर्स्ट एप्लीकेशन, और इसको P के A की वैल्यू के हिसाब से भी बोल सकता है अरेंज करने के लिए। तो ऐसे हम सबसे पहले क्या कंपेयर करेंगे, वेदर दे आर एरोमेटिक, एंटी एरोमेटिक और नॉन एरोमेटिक। अगर आपके पास दो एंटी एरोमेटिक आ भी जाते हैं, देन यू कैन यूज द कंसेप्ट ऑफ रेजोनेंस टू कंपेयर देयर स्टेबिलिटी। कम टू सेकंड, your second application of aromaticity is rate of SN1 reaction. Rate of SN1 reaction. तो ये सबने पढ़ा है, +1 से 11th से 12th में पढ़ते आ रहे हैं, MSc तक चलता है कि SN1 रिएक्शन में जो इंटरमीडिएट बनता है वो होता है कार्बोकेटायन। इंटरमीडिएट फॉर्म इज कार्बोकेटायन। तो अल्काइल हैलाइड की ये एक स्पेसिफिक रिएक्शन है जिसमें न्यूक्लियोफाइल जो है वो एक दूसरे न्यूक्लियोफाइल को रिप्लेस करता है। दिस इज सब्स्टिट्यूशन न्यूक्लियोफिलिक यूनिमॉलिक्यूलर रिएक्शन। तो इसमें बेसिकली इंटरमीडिएट बनता है हमारा कार्बोकेटायन। तो अगर आपको ऐसा क्वेश्चन आ जाए दैट यू हैव टू अरेंज द कंपाउंड अकॉर्डिंग टू द रिएक्टिविटी टुवर्ड्स SN1, तो आप कैसे करोगे? सो दिस इज एन एग्जांपल। सो आपको ये 3 मॉलिक्यूल जो है वो दे रखे हैं. दिस इज योर A and this is your B and this is your C. So we have these 3 types of organic compound. और ये पूछ क्या रहा है कि out of these 3 which has maximum rate of SN1 reaction. तो ऑप्शन वैसे ही होंगी जैसे लास्ट क्वेश्चन में थी A B C C B A like that. तो let's change them into carbocation because in SN1 the carbocations are the intermediate. So first step in SN1 reaction is cleavage of this CCl bond. This is polar bond to producing positive charge here. So how these molecules look like after losing chlorine. So this is first one. This is your second one. And this is your third one. So these molecules look like this. After losing chlorine, this is the first slow step in SN1 reaction. Carbocations are formed here. Now we will compare the stability of these 3 organic species. So first one, let's see whether it is completely conjugated or not. So all the carbon atoms and as well as this oxygen is sp2 hybridized. It means it is completely conjugated. It is flat. Now we have to count the number of pi electrons. So in case of oxygen, मैंने पहले भी एक्सप्लेन किया है, 1 pair is present in sp2, other pair is present in p, so there are total 6 pi electrons, so this compound is aromatic. Come to next. Now first of all check whether this molecule is completely conjugated or not. So this compound is completely conjugated, so you can put hydrogen here to complete its valency. So now this compound is completely conjugated because boron is also sp2 hybridized. So now how many pi electrons are there? There is 1p, 2, 3 and 4. Boron has no lone pair. So there are 4 pi electrons. So this molecule is anti-aromatic. Last compound is your phenyl cation. And phenyl cation is highly unstable molecule. Phenyl cation is highly, when positive charge appear on benzene ring, we know is a very unstable molecule. इतना unstable है कि ये कभी बनेगा ही नहीं. It's not possible, or directly you can see from here, it's not possible to break this bond. Okay. You can break this bond easily because there is no resonance here and there is a resonance with a benzene ring pi electron, so it's very difficult to break this bond. It means your compound C that will be least reactive towards SN1 reaction. So what will be the order now? A is giving aromatic, very good, it's a good compound, so it means A can easily undergo your SN1, so the reactivity of A will be more. Then your anti-aromatic, then you can say is a B, and then your C, because C will not form, because this bond cannot be get a partial double bond character due to resonance. So this was your second type of applications. Now come to third. So in third type of applications, precipitate formation, PPT formation with silver nitrate. अब सिल्वर नाइट्रेट डालोगे, कौन सा मॉलिक्यूल पीपीटी इजीली देगा? ओके, तो क्वेश्चन क्या आता है? Which will give PPT easily, or arrange them according to PPT formation. ऐसे कुछ भी पूछ सकते हैं. So now we will solve this question with the help of our aromaticity. So the compound given are, first one Br here, and it is benzene. Compound 2 is a heterocyclic with Br. Compound 3 is a simply cyclohexane with a Br, and compound 4 is Br with the 7-member ring. Now we have to decide which molecule will give PPT when they react with AgNO3. So when they react with AgNO3, what will form? The PPT of AgBr will form. It means AgNO3, this Br gets removed from here, and how this molecule look like after losing Br, it will look like this. That is again a phenyl cation, is highly unstable. It means this reaction is not possible. When you treat it with silver nitrate, it will lose that bromide ion, and it will look like this. So again this molecule is unstable. It is just like benzene, phenyl cation. Now come to third. When this molecule loses Br negative, it will look like this. It's not too much stable, moreover it is your non-aromatic compound. This is not in one plane. Now last one, when you lose Br negative from here, you will get this type of molecule. Now this is your 6pi electron system, and it is aromatic. So now which out of 4 compounds will give PPT with silver nitrate easily? The answer is this last one, because it is going to change into aromatic compound. So when it is moving toward aromatic compound, it means it is much more stable. Then next question, fourth application. Now in the fourth application we will discuss about the carbocation stability. So the fourth is here, stability of carbocation. In general, stability of carbocation depends upon the inductive effect. We explained that in general, and a 3 degree carbocation is more stable than 2 degrees and 1 degree. This is explained on the basis of inductive effect. But when such type of carbocations are given, we can use the concept of aromaticity. So suppose these 4 compounds are given. These all are carbocation, and we have to arrange them according to their stability. Say this is your compound number 1, 2, 3 and 4. So there may be 4 options. So let's start and arrange them according to their stability. So check here, aromatic, apply the concept of aromaticity. So this is planar compound, this is a 2pi electron, so this is your aromatic. B, again a completely conjugated 6pi electron, again aromatic. C is a completely conjugated but 4pi electron, is your anti-aromatic. D, this carbon and this carbon is sp3. It means the compound is not planar, so this is your non-aromatic. Now we know the stability order. Aromatics are more stable than non-aromatic, and non-aromatic are more stable than anti-aromatic. Means aromatics are extremely stable, anti-aromatics are extremely unstable, and non-aromatics in between. So let's arrange. Now we have a 2 aromatic, 1 non-aromatic and 1 anti-aromatic. Okay. The least stable carbocation is this. After that we have this. Now out of these 2, your 2 will be more stable, and 4 then 3. So this will be your order. Why the 2 is more stable than 1? That is again due to delocalization. There is more delocalization in compound 2. I bond shift here, this bond shift here like this. So it is more stable. Both are aromatic, but this compound has a more delocalization, so it's the most stable. So in this way you can arrange the compounds according to their aromatic character. बाकी कुछ और एप्लीकेशंस हैं वो हम नेक्स्ट लेक्चर में डिस्कस करेंगे. थैंक यू.